So welcome to the June DoKC Town Hall. My name is Melissa Logan. I'm director of DoKC. I am very excited to have our special guest on today to talk about data pipelines on Kubernetes, as well as how to secure your Kubernetes operator to protect your data. Before we dive in, I wanted to just ask folks who are joining us today a community question. We like to start with just what is a community question? And the question today is, what is a podcast you have been obsessed with lately? That includes our guest speakers too. I'd love to hear from you. What is a podcast you've been really obsessed with lately? I like a lot of different podcasts. I can start. I've been listening to not a podcast though. I've been listening to podcasts that focus on Britt Marling. So if you haven't heard of Britt Marling, she's a filmmaker and actress. She wrote the OA and stars in the OA. And she is just a fantastic person. She is so imaginative. She embraces curiosity and femininity in a way I deeply appreciate. And I just listened to a really great podcast with her on this show I've never listened to before called Talk Easy with Sam Fragoso. And he just has this really nice, gentle way of talking that, and they are actually friends. So it was such a lovely conversation to feel like you get to hear them, two friends just chatting about really cool topics. So that's one that I've been really into, and I'm going to listen to more of his podcasts too. What about other folks? What are you all listening to? What's a great podcast that you've been obsessed with lately?
I have a terrible confession. I almost never listen to podcasts, even though I know I should. I spent my listening time is more Pandora and
Okay.
a lot of techno and sort of
I love it.
sort of back and trance. So I'll be noting all the things that you all like and try and catch up.
That's great. You got to share some playlists, Robert.
I'll confess that I've never really been a podcast person either. I went through a phase where I was, and the only one I think that I really listened to like every episode was the You Need a Budget podcast, because I had gotten really into that app for managing finances. And so the very short episodes, and I would just binge them all. I need to get back into podcasts though. I think about this occasionally, so I'll also be watching the recommendations.
There's never ending streams of podcasts out there for folks who want them. I think that's the hard thing is what I always love hearing podcast recommendations because there are so many. So what are people that, I appreciate listening to? I always appreciate that. Well, that's great. I've never heard of that. I have a budget podcast. I've heard of that kind of sentiment before. So that's interesting. I'll have to look into that one as well. Get my budget back in order. That'd be helpful. All right. Well, if you have other ones, please put them in the chat window. We'd love to share, learn what podcast you're listening to. Moving on to just some community updates for everybody. We are very excited to announce that DoK Day North America registration is now open. DoK Day is happening November 6th. It's the Monday before the KubeCon event happens. It is a co-located event as part of KubeCon. The CFP and prospectus is in fact going to be made live end of day today. So we'll be sharing that out on social media, in our email, on Slack. Keep an eye out for that. We would love to see your submissions for DoK Day. We are looking for topics around DoK Day 2, DoK application development, DoK security, DoK use cases and best practices, DoK emerging and advanced. So you'll see all the descriptions for what those look like in the CFP. And it's going to be part of the CNCF's larger co-located event CFP. So you'll see DoK Day along with other co-located events that they're managing. And you'll be able to submit for our event that way. And they're hosting our event. We have a program committee that's choosing content for that event. Like everything we do, it should be vendor neutral, objective. How can you provide something of value based on what you're doing with Kubernetes and data workloads? So please submit your CFP. It will close on August 6th, I believe. So you've got plenty of time to get it in by then. We will be looking for your talks. The next update I wanted to share from the DoK community front is what the operator SIG is working on. So if you're not familiar, the operator SIG was created out of a need to try to help people navigate what's happening with Kubernetes operators for data workloads and projects that we as a community could help advance to make things better. Because in our previous data on Kubernetes surveys, we learned that operators are just a challenge for y'all. There's a lot of complexity. Not all of them are as mature. They have varying degrees of quality, things like this. So we created the SIG to try to help figure out what we can do as a community to improve the landscape for everyone, whether it's working with folks within the CNCIP community, within Kubernetes community, trying to advance some projects there, or external things that we're working on, like white papers and other things like that. So a few projects, we are closing out on one project. We've been working with the CNCF storage tag on a databases on Kubernetes white paper. That is coming to a close. We're doing final proofreading and editing, and the CNCF storage tag will be publishing that paper pretty soon. You'll see it on our channels too. We'll be sharing all of that external in our community as well. Great resource if you're just getting started or really want to dig into understanding what databases on Kubernetes look like. That project's coming to a close, but we have 3 different projects that are open. One is the operator feature matrix. This is a comparison matrix for database operators. We started with database operators. We are hoping to expand it to other types of operators, but there's enough complexity in just database operators. So we started there. Lots of opportunity to contribute. If you create a database operator and maintain one, then this is a project for anyone to get involved in. And you can submit your operator and just put all the features in there to be added to the matrix. And that'll be on the Data on Kubernetes website once that is, once we get all the initial kind of V1 entries from folks. The second project, which you'll hear about today, is an operator hardening guide. This guide will identify common attack surfaces for databases running on Kubernetes and define a set of best practices for securing them using operators. And one of our guest speakers, Robert Hodges, will talk about that today and how you can get involved in that project. The third one that we have working on right now, distributed systems operator interface. It's a set of best practices for building Kubernetes operators for distributed systems. That's a new project. We just started talking about it. I think it was the last meeting a couple weeks ago. So very new. If you're interested in that, come learn and join and see if you want to contribute to that. We host operator SIG meetings on a bi-weekly basis. The next one is next Tuesday at 9 a.m. Pacific. If you want more details on that, you can join the operator SIG channel on the DoK Slack. And there's an agenda pinned to the top that has everything you need to know, all the event logistics details in there, a calendar you can add to your own calendar. It's got all the previous meeting links and agenda notes and all of that good stuff in there. So we'd love to see more people participate and join that and help with any of these projects. And you can also propose projects too. So if you have something you are just so frustrated with operators and want to try to fix something, this is a place for you. We also hosted an live operator roundtable for people who are building operators themselves to understand the challenges that you have when you're writing operators. And the recap for that will be published in a blog sometime very soon. The folks at Google hosted this as members of the community, and they'll be publishing a blog on the DoK website about what that looks like, as well as some next steps. We are continuing that conversation in the DoK SIG meetings on a bi-weekly basis as well. So if that's interesting to you, please join the operator SIG. The next update we want to share is there are a number of DoK local meetups being discussed right now. So there was a Bay Area meetup that was co-organized by folks in our community that was held in May. And they're talking about hosting another one in the future. And there are now people in New York and Bangalore areas looking to start local DoK meetups. If you're interested in helping to co-organize or want to submit a talk for that or want to be involved in some way, join the DoK Slack. reach out to Hugh Lashbrook. And there's also an events working group Slack channel that you can join. We host a monthly meeting to talk about who wants to do what where and just try to help organize people. And he'll share with you what resources are available to you if you are interested in doing this. And also, if you want to host DoK content at your meetup, so you might have an existing meetup that focuses on Kubernetes, you want to have data on Kubernetes content there, reach out to him on Slack as well. We are putting together a speaker bureau of people in our community who live in different locations who can give talks in different locations. So multiple ways to participate with DoK in that way. And we have a form to submit a talk. So if someone can share that form, if you have a talk you'd like to give at a DoK meetup, we're looking for end user case studies, use cases, ecosystem talks, things like that. We have a form you can submit. It's on, in fact, the main DoK website. At the bottom, it says submit a talk. There's a form there. That's where you can get that, DoK.community. And on there, it says, where are you? And if you tell us where you are, we'll try to put you in a local meetup somewhere talking about DoK in your local community. And that is it for the DoK updates. Without further ado, we'll go to our first guest speaker. Excited to have Robert Hodges here, CEO of Altinity. He is also a co-organizer from the Bay Area DoKC meetup. He is here to talk about security threats to cloud native databases and to show what protection you should look for in operators. Really excited to have him here because this topic comes up pretty frequently in our community. Operator security is top of mind for end users as they evaluate whether to adopt an operator. It was the #1 criteria noted in our 2022 survey of 500 end users. So this is very top of mind for folks, very timely conversation. And he is leading the project that I mentioned previously about operator security hardening guide. Without further ado, I will turn it over to Robert. Welcome, Robert.
Thank you, Melissa. Thank you, Hugh. Thank you, Diogenes. Yeah, it's great to be here. And yeah, thanks for the great lead in. So I'm going to go ahead and do a share on my screen. Let me just pull this up and you can let me know if it's visible. Let me know when you see my screen.
Yep, we can see it.
Okay, great. So my talk is called Repel Boarders, and it's how to find a Kubernetes operator that protects your data. So let me just jump in and do a little bit of an intro. You've already heard what I do for a living, but I've been working on databases for 40 years and Kubernetes since 2018. Our company is an enterprise provider for ClickHouse. It's a popular data warehouse and open source. Turns out it runs very well on Kubernetes. And the reason we know that is that we developed one of the first, possibly the first operator for a data warehouse, starting back at the end of 2018. It was released in 2019. And then we took that operator and we used it to build a cloud for ClickHouse that was actually the first managed ClickHouse in both Amazon and GCP. And so we now have this cloud. We have we run hundreds of ClickHouse clusters on it. We run about 100 Kubernetes clusters. And then because the operator is open source, it's actually used for, throughout the world, there are thousands and thousands of ClickHouse clusters that run on it. And as a result, we found that we had to think pretty deeply about security. We're SOC 2 certified, like most cloud services, getting into things like FedRAMP. And so security just became increasing, the deeper we got into this, the more we started to think about security. And that led to the talk you see today. So let's start at the top. So Kubernetes operators basically make it possible to run data on Kubernetes. They're just one of those the big advances in Kubernetes that has really changed our ability to use the platform. And the basic idea behind an operator, for anybody who doesn't know what they are, is they're a resource manager on ClickHouse. They define basically you define a new resource type that represents your database, and then you can control it by submitting YAML. So if it's a simple operator, just doing, say, MySQL with persistent storage, it can be like a really short piece of YAML. It could be a few lines long. You submit it to Kubernetes. It has a resource name on it. Kubernetes will identify the operator that's responsible for that resource and forward it to it, and then the operator makes it happen. So, it means that you can, for example, set up simple databases just in a few minutes from start to finish. Now, the place where this really, simple databases are not a big deal because you could just write a deployment or write, like code the stateful sets yourselves. But in real databases, particularly data warehouses and other types of distributed data, the databases are complicated. They are large clusters. And so what you'll end up having to do to stand these up in Kubernetes is you might have to define and manage 50 or 60 or even more resources. In some cases, it's hundreds. Everything from config maps to services to to persistent volumes, so on and so forth. So you have a larger amount of YAML that you feed into the operator, but it's still pretty simple. It tends to be a couple pages of information that will set up this complex cluster. Now, the problem is that now that we've made it easy to run data, well, or at least possible, I should say, to run data on Kubernetes, well, what that means is that, okay, people are going to be interested in coming there to try and hack it. So, and so as a result, the more deeply you go into the operators and the more dependent you become on them, the more you're going to depend on the operators to actually supply the security that we normally expect to protect databases, particularly when they're running in clouds, particularly when they're running in locations where there might be network access from the outside. So what we can start with as we think about this problem is just thinking about what is the threat model that we have to deal with in databases. And this is something we've had to deal with for decades, and databases do, even on enterprise networks, people can still get in, they can still see data. This is a traditional database threat model, but it starts on the left side with sort of the application connections, and then goes all the way to the right side where you have to think about things like backups, which are actually a really great place to go steal data because they're often unencrypted, and particularly in cloud environments, it's pretty easy to expose them by accident. So there's a host of things that we have to deal with, and databases by and large do a pretty good job of covering these things. And so we're sort of used to doing things like, just to take one example, adding encryption for application connections. One important thing to think about is that you have a tendency to think about this as an application problem, but if you look at the threat model, you also need to consider the fact this is a cluster, it's a distributed system, so we also need to consider threats that arise as the servers talk to each other. Now, when we operate in Kubernetes, this threat model evolves. We have the same issues, but we also then layer in some kind of interesting concerns, particularly if we're running Kubernetes inside a cloud. And here's just some examples of the types of things that can happen. I'll just pick two. Exposed public endpoints. So if you're not careful, if you set up EKS, for example, which is a very popular managed ClickHouse managed Kubernetes on Amazon, and you just run an operator and set up a database service, if you're not careful, you can end up creating an exposed public endpoint. I think many people here probably remember the disaster where all the Mongo databases were exposed to the internet and could, without passwords or encryption, could easily be accessed. Kubernetes offers a way to do that for many databases, because if you just sort of naively set things up and set up a service, it may very well, as a side effect, create a load balancer that's publicly available. So that's an example of a new concern that we get as we're operating in Kubernetes. Another one is backups, which tend to be in object storage. You need to make sure that that's configured correctly so that only the Kubernetes cluster and the processes generating the backups can see it. and that there's no access, and even if there were access, that the data is encrypted. So these are just examples of the types of things that we now need to think about when we're operating in Kubernetes. So this is a bit of a mess, and it's a mess in the way that security always is. It's a lot of little things that across a wide range of concerns that have to be done right, and have to be done right in a consistent way. Otherwise, you end up leaving gaps. And so the obvious question is, well, can operators do this? This is just something that, I mean, the idea behind operators is to set up best practice deployments, but that should now include security. And the answer is yes. And what I'd like to do is just give a couple of examples of how operators can fix these problems. And these are things that we do ourselves in our operator and that other people are doing. So we can drill in and just show how these are not only possible to do, but they're things that you should really expect from an operator. So let's take connectivity. So connectivity is just a problem everywhere. It's complicated encryption setup. So this shows particular threats, the threat model for an application connecting through a load balancer. It could be public or non-public, but anyway, it exposes. It's a doorway into a virtual private cloud. It goes, routes through a service, and then it gets to a database. And so we could have things like, hey, the database needs a certificate. We need unencrypted or encrypted connections. We need to make sure that we're not accidentally exposing endpoints, exposing user credentials, or having a bunch of insecure ports that are just showing up on the network. So this is the kind of the attack surface. And what you can do with operators, and what it's reasonable to expect, is that operators just automatically take care of this. So for example, operators, they wouldn't necessarily generate the certificate, but they would give you an easy way of forwarding the certificate so that it becomes available to the server along with the private key, and that you have TLS correctly configured for the database so that when connections reach it, they're protected in flight. Similarly, you could, when you configure the database, you can lock down and insecure ports. Virtually every database has different kinds of ports that are just kind of open. An example that's pretty widely appears for Java-based implementations is things like JMX. That's a port that may or may not be protected. You may not think about it a lot when you're running in your own private environment, but once you're in something that's in the cloud, in Kubernetes, and potentially accessible, it becomes pretty important. Obviously, you can pass credentials using secrets. You can correctly configure the private cloud endpoint. One of the things you want to do is have a way inside the operator so that these load balancers don't accidentally turn out to be public endpoints. And then, of course, you want to have TLS encryption on the connection, which may mean that as you go through these endpoints, you have additional server, setup of certificates and things like that to allow connections. The actual configuration of the endpoints themselves, or excuse me, the load balancers themselves, in our experience, tends to be somewhat out of scope for operators, but it's definitely something where the operators can at least prevent you from creating the wrong type. So these are things that you can reasonably look for in an operator, and they're actually things which by and large we do in our own operator and other people do as well. So here's another example, kind of a completely, here's an example of what, just to give you an idea of what this might look like inside the operator. So I mentioned that the operators are just, you have a bit of YAML that sets things up. And this is a typical example of a YAML that's used to set up the load balancer here. So we see we have the service annotations. These are standard labels that are recognized by Amazon in this case, and this will create an internal load balancer. So it won't have a public IP address. And then another thing that we do is we have special annotation for ports to ensure that only the secure protocols are permitted. So this port is HTTPS. It must be that's going to be configured properly so that it's only a HTTPS. This secure client says, hey, make sure it's TLS encrypted. So, and other ports will just be shut down and not open. So this is the way this works out in practice. It just makes it easy for people to get it right. I'll give another example. Supply chains. So your operators manage things which are containers of various kinds, and you want to make sure there's some sort of program for scanning them, reacting to problems, and of course signing things so you know what you're getting and not just random software. And you also need to consider that in real systems, databases tend to have a lot of additional services that they need to work. They might be Prometheus, they might be Grafana, they might be editing tools. So those containers need to be covered as well, and not just some random software you're pulling off Docker Hub. So again, in a different dimension, you'd look for in the supply chain management for the operator, that the containers are getting scanned. It's not just the operator itself, but that it has a way of ensuring that you can use scanned containers and that those are available somewhere, and that the people writing the operator are tracking dependencies, for example, on systems you're dependent on. So in general, we can kind of summarize this as a set of features. I've just given 2 examples, but there's a bunch of security features. It's not a huge list, but this slide shows just the things that you would expect to see, ranging from making sure that default accounts are locked down and not operating with passwords, all the way to things like minimizing the amount of the number of privileges you need to run inside Kubernetes itself. Like, you don't want to give operators privileges that could allow them to bring the cluster down, like destroy nodes or something like that. And of course, software supply chain, so on and so forth. So in summary, with this, what we're looking for, this is something that users should look for, these features. And as people are developing operators, they should think about these things as features to include in the operator implementation. So there's one other thing which is kind of a hallmark of any software that's that pays attention to security, and that's documentation. So on top of all these other things, you would expect to see, and you should ask for, a hardening guide. A lot of security is just configuring things. It's not actually implementation. So if you see an operator that has a hardening guide, that's a good sign. Correspondingly, if you don't see it, you should either write one or ask for one to be written. So one of the things that in doing this work, what we realized was that there is kind of a gap on operator security, and it's not that people don't do it, but there's a lot more that there's just some standard things that everybody should do, or at least consider in their implementations. And so to try and fill that gap, what we started in Data on Kubernetes is a project to develop a security and hardening guide for DoK for operators that will just give developers sort of a set of things they should say, standard features that they can implement and that consumers can look for. And the idea is to be kind of checklisty. It's just like, secure default accounts, got it. And yes, obviously you want to, you'll do it in some way that's appropriate for your database, but the point is you're doing it. And we would like to invite you to participate in this project. It's just getting off the ground. The next step is to write to begin writing a white paper to try and pull these ideas together, and also build off, without and try and build off stuff that already exists in Kubernetes. One of the things that's really helpful is to get the experience from people who've done multiple types of operators for databases, and that will make this a better project and more broadly useful. So here's some background information. I will say that one of the inspirations here is OWASP, which I think many people who do security are familiar with, but that gives a great set of guidelines for building applications. The idea behind this is to create something similar for operators, particularly operators on databases. And with that, the talk is complete. I'd be happy to answer questions, but Melissa, I'll turn it back to you.
Yeah, no, I'm glad that you talked about this project. As you were talking, Robert, it made me think the operator feature matrix that Alvaro has been working on, we don't have a security portion of that. I think maybe we were chatting about this last time. We should make sure that there is this, what's that security checklist, or does it have a hardening guide or something like that as one of the features?
Exactly.
Yeah.
And yeah, one thing that is a really important point. So we have the operator checklist. This one, for now, we're trying to just scope it to security because it's something where it feels like we can make pretty rapid progress and give people just like a kind of a wallet-sized list of. Yeah. I mean, obviously there'll be more documentation behind it, but we can give people a short checklist of stuff they should look for, and hopefully, raise the level of security for operators across the board.
Yeah, definitely. It's a great place to start. And I see a question we have from Amit. Amit, do you want to come on live? Can Diogenes, can you unmute and ask your question? There we go. All right, welcome.
Hey, thanks, Melissa. This is a great details. I think we are trying to build a similar way operator as well. And yes, security is the key things. And yes, we should take care, as you mentioned, the details from left to right, how to do the TLS to encryptions to the secrets and all those. Just quick question. I was trying to understand what operator you're talking about, what kind of framework are you using? Are you using operator SDK kind of framework or any other framework?
As it happens, we're not. We started writing our operator before a lot of those frameworks existed, and then they've kind of changed over time. And so, in fact, I think one of the key things here is not to be particularly prescriptive about a particular framework, but instead to try and kind of the way that OWASP does, to identify things that are common to all operators, regardless of how they're implemented. Because we'd also like many of the, I think one of the key things here is to ensure that the existing operators that are out there and popular can adopt this without having to change their implementation. So,
yep. Understood. Got it. And Melissa, I'm sure this presenter is going to share, but I think, Robert, I am interested on the Git link, which you just share about the recent project you started about the security of the operator. Yes. I think we would like to be a part of that. So if you can share that GitHub links.
Wonderful. Melissa, I'll just stick it into the chat. Hopefully I can. I'll go ahead and share a couple links on the chat, and feel free to DM me on my name, Robert Hodges. You can find me on the DoK Slack.
Sounds good. Thank you. I appreciate your help here.
Yeah, thank you, Amit. Welcome.
Awesome. Yeah, thanks, Amit. Appreciate it. I see Greg has to drop. Thanks for joining, Greg. Fantastic. Great question. And we're excited to have people join that project. As I mentioned, it is pretty new. I mean, we're just getting started. So this is a great time to start getting involved in that. We'll add the links into the chat window, and you can also join the operator SIG channel on Slack. That's where we do a lot of where we host conversations about this.
Cool. Melissa, I'm going to go ahead and post those links in, and then I'll drop to go to my next security talk.
Sounds great. Thanks, Robert. Appreciate it.
Thank you, everybody. Really appreciate it.
Fantastic. Well, great. And up next, we have Matt Manzensky of PayItGov. Very excited to have you on and talk about how they have been unsticking themselves from glue. So they recently migrated all of their data pipelines to Argo workflows and Hera. and just trying to get that under control. Just completed that. We're so excited to hear about how that is going and what challenges or pitfalls you ran across along the way, and what kind of hope and optimism you can share for anyone who wants to do this in the future. So welcome, Matt, and please take it away.
Thank you. Thanks so much, Melissa and Diogenes and everyone at DoKC. Yeah, so can everyone see my screen okay? I'm not really a Zoom user, so thank you. Thank you very much for giving me the opportunity to talk today. I'm excited to share a little bit about our journey into a Kubernetes native data iteration. So I'll give a little bit of background. I'll talk about our legacy data infrastructure a little bit. I'll talk about our first attempt, our first iteration of a new data warehouse, some of the challenges we ran into with AWS Glue in that build out, and then a migration into Argo workflows and sort of where we are today. So first, who's PayIt? We are a SaaS platform. We provide a self-service portal for essential government tasks. Depending on where you're located, if you're in the US or Canada, you might have used one of our applications to do something like renew a vehicle registration, pay personal property taxes, pay utilities or water, pay your utilities like water or refuse, get a copy of a professional license, all of these like little kinds of day-to-day mundane government interactions we're trying to sort of make easier. For agency users, we also provide a self-service portal and kind of a back office tool to allow doing things like updating the status of an application, looking at payment details, issuing refunds, viewing reports, handling, disputed charges, things like that. And our clients include various cities, counties, and states in the US and Canada. Our platform, we sort of pride ourselves in being cloud native. We've been deploying Kubernetes in production since early 2016. Our platform has always run in a microservices architecture, almost from the beginning on Kubernetes. It's all AWS. We're in EKS now. In late 2022, we migrated to GitOps with Argo CD for all of our application deployments. All of our Kubernetes infrastructure is also now managed with Argo CD. We're also big users of Terraform. A lot of our database infrastructure, et cetera, is all managed with Terraform. I think now in total, we have 6 environments across 14 clusters, multiple production environments for US and Canada, and production could be split into a couple different clusters depending on restrictions for things like card processing, et cetera. Our US production environment is in the AWS Gov Cloud. And I think we're something like 130 microservices today. Most of those are Java, a couple are Node.js. Our transactional data store is MongoDB. We have one big MongoDB cluster that serves most purposes, and we've started kind of slowly migrating some things away from self-managed MongoDB and into AWS Document DB, depending on service use cases where they need special handling. Our infrastructure for data, a lot of it dates back to fall 2017. Before we actually had a data team at PayIt, our infrastructure team stood up a database that we call the oplog database, or sometimes the oplog warehouse, because its source is the MongoDB operations log, or oplog. If you're not familiar with MongoDB, the oplog is a capped collection, which the members of a replica set use to stay in sync with one another. So you write against the primary member of the replica set, it writes to the oplog, and the secondaries will read the oplog and apply those changes to themselves. And we have this sort of set of 2 Java services and an AWS Kinesis stream that reads messages in that operations log, publishes them to AWS Kinesis, and then this other Java service consumes those records from Kinesis and writes them as JSON to this Postgres database. And it's very dynamic. It uses a Java ORM, and it creates tables dynamically as new records are inserted. And so you sort of end up with this, not really a warehouse per se, but it's a Postgres copy of the MongoDB upstream transactional database. This oplog database, this Postgres database, also has been the source for most of our financial reconciliation reporting that the data team owns. The benefits of this approach are it's very low engineering cost because it's so dynamic. And it really was great for us as an organization. It bought us a lot of time to be able to have sort of this relational analytics database without requiring the investment in the data team at that early point in the business. And you sort of basically get your data immediately, right? As changes are applied to the, the oplog and the members of the secondaries in the replica set, they're also effectively immediately available in this Postgres copy. So you can sort of see data as it happens, even if you're in the analytics database. However, it's got drawbacks, right? It's very tightly coupled to MongoDB specifically. AWS Document DB implements the MongoDB specification, but the operations log is not part of that specification. It's an internal feature of MongoDB, and DocumentDB doesn't support it, right? DocumentDB is separate compute and storage versus Mongo. It's pretty different. So as we migrate a service from MongoDB to DocumentDB, it no longer is able to be replicated to this analytics database. And so that's a decision we've had to, do I create a new service against DocumentDB or MongoDB? Well, does it need to be present in this analytics database? Okay, it has to be in MongoDB. We don't like having that, our hands sort of forced in that way. Tables are created dynamically, but you don't get anything for free around indexes or constraints. And so you often get into scenarios where there's a new database collection in Mongo, and that creates a new table in the warehouse, and then people start trying to query it, and they say, hey, it's not performant, and you have to go look at how it's being used and where you can add indexes and do it all kind of after the fact rather than be proactive about it. Also, everything is JSON, right? MongoDB is BSON, essentially just a JSON blob coming in through AWS Kinesis, and so this application that writes to this oplog database does one level of object flattening, but if you're selecting information from this database, you'll have to do a lot of further flattening, lateral joins, JSON-B array element, a lot of complicated queries to be able to join two tables together. And that's sort of a burden on some of the business analysts who maybe don't have that skill set. And finally, it works fine until it doesn't, right? It's great that it's a low cost of ownership. It's great that it's hands-off. And then something goes wrong and everybody's scrambling because there's not a lot of familiarity with the processes around it because it's been hands-off. So for a lot of reasons, we were looking to migrate away from this. The data team has grown. We've hired a real ton of database specialists onto our team. And so we've said, okay, now's the time. We're going to build the next generation PayIt data warehouse. So what does that look like? Well, we had some design goals we wanted to meet. The big one is support our needs in the future and today, right? Where we were finding that our current approach had served our needs well for about 5 years, but it's showing its age. It's not going to meet our needs for very much longer. So we need to meet our needs for today, and we need to build for the next 5 years or longer. So historically, a lot of the needs from that analytics database have been reports that the data team, like Python code base, runs and sends out daily to our client users to do financial reconciliation, a record of what was paid and what was transacted and what we will be dispersing to those clients, et cetera. However, we're also now getting to a point as a business where we want to do a lot more BI. We want to have sophisticated dashboarding tools. We want to be exposing customizable analytics dashboards to our agency users inside our back office tool. We want to support multiple BI front ends. So we have AWS QuickSight that we use for a lot of internal uses. And also we kind of white label in our admin tool to expose to agency users. We also have an executive team that wants to live in Tableau. So with that in mind, we want to push a lot down into the database and rather than have it implemented in 2 different BIs. We also really wanted to support this idea of any data source is a first-class data source. Remove the tight coupling that the previous database had with MongoDB. We want to be able to support MongoDB. We want to be able to support AWS Document DB. We want to be able to support any third-party data source. We want it to be performant. We want it to be managed via automation. Like I had said on a previous slide, we have, 6 environments. We want to be able to put this in all environments and not have to have data engineers sort of manually applying database changes. And we also just want it to be manageable, period, right? The data team has grown. It's still not very big. There's 3 people. We want it to be able to sort of handle all of it ourselves as much as we could. And so we started out in a way that had a lot of similarities with the previous model. So instead of this Java application that would read the op log and publish to AWS Kinesis, we had a new Java application that would read from the MongoDB change stream and publish to Apache Kafka. I had said that this first generation of infrastructure was created in 2017. Kinesis, I think was selected actually because Apache Kafka wasn't yet available in AWS GovCloud. Since that time, we had adopted Kafka more broadly, and so the Kinesis use case was kind of an outlier. So we said, okay, we'll adopt Kafka instead for pushing this data around. And also the previous infrastructure, the previous database had been created and put into production, I think just a couple weeks before the MongoDB change stream API was like made public. And so the change stream API, unlike the operations log, is a public API. DocumentDB does support it. And so we thought, okay, we'll build this against the change stream and we'll get MongoDB and DocumentDB support. And so this Java application reads the change stream messages, puts those into an Apache Kafka topic. We have an Apache Kafka Connect service in our managed Kafka provider that writes that to AWS S3. And then that's kind of our data lake. And then we also have a Postgres operational data store, and we'll have this AWS Redshift dimensional warehouse. And the data team had been very familiar with AWS Glue. We'd been using it for years for all of our sort of financial reporting jobs. And so we thought, hey, Glue is an ETL tool. We need ETL. We're just going to leverage Glue. This is what it's built for, right? And manage everything that we can in Terraform for infrastructure and AWS resources, and things within the database we'll manage with Liquibase. Liquibase is an open source tool that allows you to automate database changes from Git. And we ran into some challenges. Managing AWS Glue with Terraform. Did I skip a slide? I did not. Okay. Managing AWS Glue with Terraform got really challenging really fast. We had tried to implement our Glue jobs as sort of small focused jobs that would do one thing. And then to have a Glue workflow that sort of called them all in the right order so that one would run dependent on the previous one's success, or you'd have a failure handler if the previous one failed, that kind of thing. And to do a Glue workflow like this, you have all of your jobs, and every job also has to have a separately defined trigger, which is the conditional, run the next thing if the previous thing succeeds or fails, whatever that definition is. And you can see the diagram here. The words aren't important, just the complexity is what I want to signal. We had 43 jobs. Each of those had its corresponding trigger, something in the neighborhood of 85 or 90 resources managed with Terraform. And we were only pulling in from the platform a tiny percentage of the data that we wanted to expose in this data warehouse, right? Like, we're a payments company, we process a lot of payments. We had started by pulling in sort of the core payments collections from MongoDB. We hadn't yet pulled in any of the customer information or the information about what accounts and bills were being paid, any of these other things. We had just been pulling in a small number of these payment collections, and our workflow was already so complex that a pull request review just to run Terraform plan could take 40 minutes or an hour or more. Very cumbersome. And it became apparent pretty quickly that it wasn't going to scale very well, because we have 400 database collections in Mongo, maybe more. We wanted third-party sources again, right? This is very complex. And furthermore, just the developer experience was really poor. We had been coming from this AWS Glue background where we were just using the Python shell environment, just running pure Python scripts for our financial reporting. With this data pipeline, we were using the Glue ETL, which is PySpark, and it was really challenging to set up a local environment to run PySpark. We had this new JVM dependency for our local developer environment. We were having to jump through hoops to get a test in GitHub Actions that would stand up the Spark JVM resource and run tests. It was very hard. AWS Glue, I think, no longer publishes a Docker image for the current version of Glue ETL, so we couldn't have a good way to replicate the Glue environment locally. And there are ways to do this within Glue with endpoints, but that was really hard to set up as well. And so we found ourselves with this workflow that really wasn't ideal. We had an existing Glue job, and we would copy it in the Glue console, make our changes there, run it, and see if it succeeded or failed. It was very difficult. And the ETL, extract, transform, load order was also really hard for us because it was difficult to find what had failed. If you see an error, you have to go back and sort of try to replicate the data frame at that point and see what the error is. We had a lot of problems. We also were just spending more time managing Glue and managing this environment than we were actually solving business problems. Right? We had to write our own handlers to say, record the job's success or failure, record when it started and when it stopped, all these things that sort of Glue didn't provide even in this workflow idea. And fundamentally, that meant we weren't able to ship as often as we wanted. We had all of these complicated steps that had to happen before we could deliver to the business, hey, here's a fact table that you can hit in your BI tool. So what do we do, right? We have this problem. We can't deliver quickly enough. Our workflows are cumbersome. We decided to throw everything away and start from scratch, essentially, right? Remove all of the complexity, like, hey, this isn't working, that we have all these hoops to jump through, only to deliver a fact table and find that in the time it took to build this out, requirements have changed and they're not looking at it now, right? We want to be able to ship quickly to the business. We want to remove all the complexity we could and focus on tools that we can use out of the box or existing open source tools, things with good documentation and good communities of practice around them. And we really just were frustrated by the pace at which we were moving. We wanted to move really quickly and we were not. And so over sort of holidays, end of 2022, beginning of 2023, we ended up on selection of some core tools that we were going to use to propel ourselves forward. Meltano and DBT were really big ones for this, and I'll get into a little bit more detail on the next slide. But Postgres over Redshift was one where we said, you know what, we can do Redshift later. Postgres works great for us now. The JSON handling is great. We know how to make it performant. Consistency with the other databases we own. We're just going to go all Postgres and no Glue, no Terraform. So Meltano, we actually sort of discovered by accident as we were researching data transfer specifications, or I forget what search term we were using, but we found the Singer specification, which the paid tool Stitch is built on, Stitch data. Singer is an open source specification around data transfer. It defines sources and destinations as taps and targets, and it defines a schema for data moving between these two things. Meltano is an open source CLI tool built on this Singer framework that adds a lot of useful abstractions over it. There are hundreds of open source connectors. It's just Python. There's no JVM. There's no additional complexity there. The user experience is great. I can run it locally, easy peasy. And it supports utility plugins. So I can invoke DBT, the open source DBT core plugin within a Meltano project. I have this one mono repo that contains everything. It's deployed all at once. It's all together. It's great. But, right, how do I run this CLI program? I can run it locally. That's great, but that doesn't scale. A lot of people in the Meltano community run Meltano in production in Airflow or in Dagster. And again, we are trying to limit all the complexity that we can. So I don't want to adopt Airflow just to run this other tool, right? I don't want to adopt Dagster just to run Meltano. Those are complex things we didn't want to do. But we are a cloud native shop. We've been running on Kubernetes for a long time. We have a lot of Kubernetes experience on our platform engineering team. Let's just run Meltano in Kubernetes, right? Meltano is published with a Docker image. It's easy to put in a container. Kubernetes is great at running containers. Oh, wait, this isn't a service. This isn't something that you start up and it's just going to stand indefinitely there and serve requests as they come in. This is a workflow. It's got to start and stop. Well, it turns out Argo Workflows solves that problem too. It gives us a way to run workflows, jobs that start and stop and can be scheduled and can have relationships with other jobs in Kubernetes. And so we can leverage all of our existing Kubernetes infrastructure. We can use our Argo CD GitOps deployment strategies to deploy these things. Our logging just works. Our distributed tracing just works. And so we went whole hog with Argo workflows. And again, we ran into some complexities there. We have a lot of workflows. I think just from our data pipelines for this new data warehouse, we probably have 500-600 across our environments. And now in the last couple of weeks, I think we've added something like 2,000 more Argo workflows jobs. So it very quickly became sort of infeasible to manage the YAML ourselves. But there's a great solution for that too with Hera, which is a Python package available on PyPy, the package index, that provides an SDK for Argo workflows and Argo events. And so we're a data team, we do Python and we do SQL. We can stay in Python the whole time now. We can write our Argo workflow definitions in Python. We get type safety, we get validation of the arguments we're passing. It's simple to script, and I can say, here's a list of inputs, generate a workflow for each of them. And we can hook that into our GitOps workflow really easily, because on any of these Hera resources, there's a function that produces the YAML. So I can make a pull request against my mono repo to add a new Meltano job, to add an Argo workflow definition in Hera in Python that runs that Meltano job. And when that PR is merged, the YAML is automatically put into the GitOps repository and it just goes out. All one PR is great. So I know I'm a little pressed for time. I'm going to try to wrap this up real quick. The short version is we are moving immeasurably faster now with Argo workflows, with Hera, with Meltano, with dbt than we were with AWS Glue. In all of 2022, standing up the data lake, standing up the operational data store, standing up Redshift, standing up these Glue pipelines, with all of the effort we put into that over the course of an entire year, and granted we had other commitments, we really didn't have much to show for it. We had, I think, 2 fact tables and related dimensions that were accessible to the business users in the BI tools. And that was too few, right? That's not enough of a deliverable for that much effort. Since beginning of this year, I think we have exposed to the business in the BI layer 170 Mongo collections, a bunch of collections from our AWS DocumentDB collections, a bunch of external data sources, and we can turn data around so quickly now. Again, I mentioned it's just really one PR to do everything, to add the Meltano job, to add the Argo workflow, to add the DBT transforms. We can turn around a request for new data in the warehouse within a day. And that's really been critical for some of the things that have come up recently where the business says, hey, I really need to do this presentation. I'd really love to have this data, but I don't see it. We can turn it around in time now. And then it's there for everybody. It's updated automatically with the Argo schedules. It's been really wonderful for us. So thank you everyone for letting me share that part of my journey. I'm happy to entertain any questions in the DoKC Slack or here in the chat or wherever. Thank you.
So Matt, thank you. That was really great to see your journey and how it's so much better now looking at your last slide. I know we're at the top of the hour, so if you do have questions for Matt, he is on the DoKC Slack. Just reach out to him there. There is a few channels about this topic. You can join those channels or reach out to Matt directly, or just let us know. We're happy to connect you with Matt. But thank you. That was fantastic. I'd love to follow up with you in about 6-12 months and see how your journey is still going.
Yeah, I will love that.
Yeah, it's always great to just kind of check in and there's always more learning to be had with these things. So we do have just our last thing is a DoKC quiz. So Diogenes, if you want to pull that up now, it just takes a few minutes. This is if you play, you have an opportunity to win our really cool Run DoK t-shirt. I think it's really cool because I love Run DMC. And just pull out your phone or your computer and you can put the quiz code in the app, and then you can play. So Diogenes, do you have that quiz for us now? There we go. Okay. Any players going to join us today? Anybody gonna? Oh, code again. So there we go. 18093913. And just a few short questions. So as we're kind of waiting for people to join, if you read a lot of our DoK reports or listen to what we're saying on these calls, you have a pretty good chance of winning stuff. So join the quiz. Yeah, so Diogenes got the link in there, menti.com, put that that code in there and you can join. And we'll just go ahead and dive in. Let's start our quiz. Okay, what is the #1 criteria organizations use to evaluate operators? And we did say this on the call, so I hope you were paying attention. Security, ease of use, easy to maintain, or feature set. Which one of those do you think is the #1 criteria organizations use to evaluate Kubernetes operators? Okay, so security, whoever said security, that's something that that's one of the reasons we were talking about creating a security hardening guide, because it's such a hot topic for folks. So we've got Guillaume, #1. Awesome. Congratulations, in the lead. Everybody's got to catch up here. All right, question 2. What do we got? How many Kubernetes operators do most organizations use on average? This was a bit shocking to me. This also came from 2022 DoK survey. This was surprising to many of us as we got the results back. But 3, 20, 9, or 15. 20 is right. That was it was surprising to see people using so many different operators on average. Some, in fact, were using much more, many more than this. So who do we got now? Who? Anybody jump into the lead? We've got Guillaume still in #1 spot. Okay, so last question, really quick quiz, just for fun. What do we got here for folks? What level do most organizations require operators to perform at? So this is based on the operator framework. 1, basic install, 2, seamless upgrades, 3, full cycle, 4, deep insights, or 5, autopilot. We asked this in our survey. Where do people want their operators to work? So it's actually deep insights, like 4 and above is what people said in our survey. They really want these operators to work on a very kind of, eventually automation, but very deep insight observability layer 2. So not just like, basic stuff, but really advanced. That's where they want to see their operators. So we have Guillaume who won. Awesome, Guillaume. Congratulations. Please get in touch with Diogenes on the DoK Slack. If you can't find him or can't remember his whole name, that's okay. Find me or Hugh or Diogenes or someone from the DoKC staff and get in touch with us and we will get you your t-shirt. So that is it for our call today. Really appreciate you all staying a bit longer so we can join. Thank you to all of our awesome presenters, fantastic content. If you have questions for anybody, get in touch with us on the DoK Slack and we will see you in July. Thanks, everybody. Have a good one.